So this question says, write a quadratic equation with real number coefficients if one of the solutions is 6 minus 7i. In other words, there's no real number solutions, right? You understand that? That's what it's saying. These are complex, so there's no real solutions. If they tell you that this is one of your solutions, then what do you know another solution has to be?
The conjugate.
The conjugate, which is 6 plus 7i. So what you could do is you could write it like this. X minus 6 minus 7i, that's one of your zeros, or one of your factors, and x minus 6 plus 7i. And then you could multiply those out. But multiplying that out would be very complicated because you'd have to first distribute the negative, and then you'd have to multiply it 1, 2, 3, and then 1, 2, 3, and then 1, 2, 3, and add like terms, and it would all work out. It would just take you forever. Or there's a better way to do it, and it's called this. And this is how I write the formula. You know that the quadratic equation, if you have two zeros, then you know this formula, x squared minus the sum of the zeros times x plus the product of the zeros. That's the formula. And to prove it to you, what if I told you that your zeros were 2 and negative 3? How would you do this? You would do x minus 2 and x plus 3, and then you would do what? X squared minus 2x plus 3x minus 6. That's x squared plus x minus 6. What's this number right here? What's 1 equal to? It's the opposite of the sum of the zeros. What's the sum of these two zeros? Negative 1. What's the opposite of negative 1? Positive 1. And that's why there's a positive 1 there. And what's the product of my two zeros? If I multiply these together, what do I get? Negative 6. There's my negative 6 there. I'm adding negative 6. Okay, so it's a pretty cool little trick, right? It's a really cool trick when it comes to complex numbers. So let's use that same property. Instead of having to do this mess right here, all I'm going to do is the sum and the product of my two zeros. What's the sum? 6 minus 7i, 6 plus 7i.
12.
What do those add to? 12. What's the product? 6 minus 7i times 6 plus 7i. Well, 6 and 6 is 36. Negative 7i times positive 7i is negative 49i squared. And what's I squared? It's negative 1, so this is plus 49. This is 36 plus 49, which is 85. 85. Remember, the inside and the outside would cancel each other out because they're conjugates of each other. So what's my quadratic equation? Let's use this formula. It's x squared minus the sum times x plus the product. There's your quadratic. That's the shortcut way of finding a quadratic equation given zeros. And it really works well when you're given complex zeros. If you don't believe that that's true, do this problem over here, multiply that out and simplify it, and you'll get this answer, but it'll take you a heck of a lot longer to do it.